Hi girls, we're going to have a look at how to find the midpoint of the midpoint between 2 points. So I've got a point here, that's the point 2, 3, and a point here, that's the point 6, 5, and we're going to see if we can find the point that's halfway between those points there. So just looking at it, I can see that I need to find a kind of average of the x's to find that point there. Sorry, my pen's a bit wonky. An average of the x's to find halfway between, and an average of the y's to find halfway between the y's. So really that's all we do to find the midpoint. We average the x's and we average the y's. If you can remember how to do an average, all we do is we add the two x's, so 2 plus 6, and then we divide by the number of things we've added together. So in this case, we've added 2 things together, so we divide by 2. Same for the y's, we add the 2 y's together and divide by the number of things we've added together, which is 2. So let's have a go for this example. The midpoint will be, the x-coordinate will be 2 plus 6 divided by 2. So that gives me the first coordinate of our point, and the second coordinate, the y-coordinate, will be 3 plus 5 over 2. So working out what that is, 2 plus 6 is 8 over 2 is 4. 3 plus 5 is 8 over 2 is 4. So the point 4, 4 is my midpoint. Let's just go and have a look. 4, 4, exactly. Beautiful. Okay, so that's how you find a midpoint. Add the x's, divide by 2 to get the x coordinate. Add the y's, divide by 2 to get the y coordinate. Let's have a look now at finding the distance between 2 points. So I've got the same 2 points here, and I want to find the distance between 2, 3 and 6, 5. Now what I notice about this line that I'm trying to find the distance of is that it is the hypotenuse of a right angle that I can draw underneath it. And this is the right angle that I'm quite familiar with. It might be a right angle that I draw to work out the gradient. So I've got the rise here and the run here. And I can find the rise and the run easily. We know how to do that. The rise is the difference between the y's, 5 minus 3, which equals 2. And the run is the difference between the x's. So 6 minus 2, which equals 4. Finding this out can help me to find the distance between the 2 points if I use Pythagoras' theorem. Remember that from last unit? Apparently I spell it incorrectly. Pythagoras. Anyway, Pythagoras said that if I square the 2 short sides and add them together, it will be equal to the square of the hypotenuse, or the long side there. So the distance that we're looking for, we'll call this d. So d squared will be equal to the rise squared plus the run squared, which equals 4 plus 16, which equals 20. Now this is d squared, so to find d, I need to find the square root of 20. And I'll just go and get the calculator, which is here somewhere. And the square root of 20 is equal to 4.47 to 2 decimal places. Okay, just to consolidate this idea, let's try another example. This time I'm trying to find the distance between A, which is 1, 2, and B, which is 6, 4. So we'll call that distance D. And I know that D squared is equal to the rise squared plus the run squared. So what is the rise? It's 4 minus 2, which equals 2, and the run is 6 minus 1, which equals 5. So going back down to here, D squared is equal to 2 squared plus 5 squared, which equals 4 plus 25, which equals 29. Remembering that this is D squared and I'm actually looking for D. So D is equal to the square root of 29, which equals, I'll bring our calculator back, 29 square root 5.385. I think the best thing to do now is to try some examples. Go ahead and look at exercise 4H in your textbook, and particularly skip 1, 2 and 3 and go straight on to 4 and 5, and then do sum of the rest. Okay, thanks girls, see ya.